Hello, my name is Caleb. I am lead cloud engineer on H&R Block's platform team. Today, I'm talking about how the Terraform Cloud API can be leveraged to manage ephemeral workspaces. I will be using a real life scenario to provide an introduction to the API. If you're already familiar with the Terraform Cloud API, hopefully you'll still find something in this presentation interesting. I find it useful to have a real life scenario to give context as to why you'd use a technology instead of having examples that only exist for the purpose of the example. So with that in mind, this is a scenario that we had at Block that we used ephemeral workspaces to solve. Many larger organizations, and we are no exception, when we have larger team, a number of teams that need to deploy resources in a self-service manner, we need to, before they are able to deploy anything, we need to create a landing zone for the application team's infrastructure to live in. This landing zone can contain a number of different things, not limited to, but including all of the SPNs and service accounts that the automation needs to deploy infrastructure, all of the governance policy, all of the guardrails, access to private networks, and all of the other required infrastructure needed in order to deploy an application. And that's also including the Terraform workspaces and everything else that goes with that. This is a problem because those automations, even though all of those pieces can be automated, a lot of them require elevated permissions. And in a lot of cases, in order for an application team to deploy a new environment, they need to go through some type of approval process in order to add that environment to their application infrastructure. This adds a high friction process to spinning up new environments, and it makes it more difficult for application teams to be more nimble. Makes it difficult to provide training for their newer developers or newer team members. It's difficult to do proof of concepts that don't necessarily belong in their actual application environments. So in order to solve this, we have created a library of ephemeral workspaces with pre-deployed landing zones. So those workspaces and those landing zones already exist, are available for engineers to use. And when they check one out, they are given access to the pre-deployed landing zone. They can deploy their infrastructure, deploy their application, do the testing, do the training, the lab work for the proof of concept that they want to work on. And then when they're done, it gets checked back into our library. All of the infrastructure that they had deployed is automatically cleaned up, and that workspace becomes available for someone else to use. In order to support that, we use the TFC API. So I have a handful of examples of API endpoints that we use to manage access to the library workspaces and to automate the cleanup process. The first thing I want to show you is what different tools are available to be able to work with an API. One example is Postman. It's a graphical tool that makes it really easy to do to experiment with an API. You can change the values in the UI, send a request, and get the results back. And it's really easy to see what's happening and iterate on that. It's a very easy way to get familiar with an API that you don't otherwise have experience with. Curl and PowerShell invoke REST method are two very common ways to use APIs in scripts. Curl would be part of Linux or part of Bash, and PowerShell and invoke REST method is a PowerShell method. Both of them do functionally the same thing. As part of a script or as part of a command line, you can reach out to an API, send the request, and then get a response back, and then act on that response with logic in your script or whatever other automation that you choose to build in that. My examples today are in Python, using the requests library in Python. I find Python to be a lot more cleaner and straightforward to use, and is easier to, or more reliable when you have mixed environments. So Python is going to behave the same, whether or not it's in a Windows environment or a Linux environment. The first thing that I want to talk about is how authentication is handled by TFC. If we look at my example here, we have we're using two different tokens for this example, a team token and an org token. TFC also has user tokens. User tokens are used specifically are generated by the user account associated with that user account and have the same permissions as that user account. The team token is associated with a team or group in TFC and has the same permissions as that team. The org token is set at the organization level and has administrative privileges over the organization, but is not capable of running any infrastructure changes. So you can't do a plan or apply with an organization token, but team and user tokens can do plan or applies if their permissions are appropriate. The basic structure of an API call for TFC is to include the token as a bearer token in the authorization header, and to set a content type header as application/bnd.api plus JSON. This is going to be the same for every single API, for every single API call, every single endpoint for the TFC API. In order to demonstrate how the authentication tokens, we're going to be using the account details endpoint, running two GET requests, one with the team token in the header and one with the org token in the header. And then we're taking the JSON result and we are extracting the username from that result. If we look at the documentation for that endpoint, we can see that we can see an example of what that full result would look like. We have a data object with ID and type and a number of attributes and relationships. These are other objects in TFE that are related. In this particular case, we're going to extract the username from this, and we're going to display it to the screen. So if we go back to my example, and then we run it, it is going to do two different GET requests to TFC, and then it is going to return the usernames for those tokens. And because it's a team token, an organization token, we say API team and API org. And this is the name of the org that token belongs to. If one of these was a user token, the result would be the name of the user that the token is associated with. So that is how authentication is handled by TFC. The first thing that we actually have to do if we are going to support ephemeral workspaces is to add team members to the workspace that we're going to use. So if we look at the organization signed into right now, you can see that I have 3 workspaces that I have access to. These would be the workspaces associated with my application. We have a dev environment, a production environment, a QA environment. Now, if I have a proof of concept that I want to do, or if I have a lab that I want to do, or if I have any training that I need to do that requires deploying infrastructure or deploying my application, I don't want to make those changes in any of these environments. The rest of my team is doing other work in these environments to add features to the application. So I need to check out an ephemeral environment from our library. In order to do so, I need to be added to the team that provides access to one of those library workspaces. And the API call to make that happen is the team membership API. If we look at the documentation for team membership, we can see that we have a couple options for adding users and a couple options for removing users. If we want to remove or add a user or remove a user, we need the team ID ahead of time. And then we make a post to this endpoint with the information about the user that we want to add, in this case, the user ID. So we need to make sure that we have that information ahead of time before we make the add or before we try to add that person to the team. And if we look at my example, we look at our next example, we have, in order to add a member, we use the org token because it has administrative access to the teams automatically. We don't have to add any additional permissions to it. And we also know that the org token cannot trigger runs itself. We set our headers, which is the same as we did before. These headers are going to be the same for all of the examples. We set our base URL, which is the base API URL, app.terraform.io, which is TFC, API, v2. We have our organization name, which we will need, and then we have the team name that that is responsible for giving us access to our ephemeral workspace from the library. And then we have the email address for the team member or for the user that we want to add. So we have to do some information gathering first, and that's going to take two API calls. The get call to the teams endpoint to get the list of teams using the team name in order to get the ID of the team that we need to add a user to. And then we have another get call to organization memberships, which will give you a list of all of the users in your organization. And then we search that list for the team member that we care about. And then we add and we extract that user ID from those results. The next thing that we need to do is we need to make a post request to the team relationships organization memberships, which will add a user to the team specified. So we have our base URL, and we have the team ID, which we got in the previous call. And we also have, because it's a post, we are also including a body or data payload. That is JSON, and it is structured with a data list, which would be a list of every user that we're going to add, but we're only adding one, of the type organization membership, and of the ID, and it's the ID of the user that we extracted in the previous request. In order to, and then we have the success, then we print, in this example, we just print if we have a successful addition or if we are adding, or if we have an error message. So if we run this, we have successfully added myself to the team. And if we switch over to the list of workspaces again, you can see that I have been added. This is now available on my in my list. It's now a workspace that I have access to. So now that I have access to it, I can deploy my infrastructure. I can do my test and do my my proof of concept, whatever it was I needed this workspace for. Now that I'm finished with this workspace, I need to return it. I need to be removed from access to the workspace, and any resources that I have deployed need to get cleaned up The process for this is, for removing myself from the workspace, is very similar to the process of adding myself to the workspace. The API call is nearly identical, except for the fact that it uses a different request method. So if we go back to our examples and we look at remove member, all of this is the same. We're still getting the team ID, we're getting the user ID, we're building our body payload, and then we do a request to organization memberships, or team organization memberships. However, the request method in this case is delete instead of post. So if you run the delete instead, we get a success or a fail. User was removed from the team. And then if we go back to the example, you can see that I have been removed from that team and I no longer have access to it. There is one more step to manage when we are, after we've finished managing our team membership, after adding a user to give them access, after removing the user to remove that access. When we're returning the workspace, we need to make sure that that workspace is cleaned up. Anything that the person who had checked it out is no longer there. And there's a couple different techniques to do this. One way is to trigger a destroy run, which is fairly straightforward and only takes a single API call. However, there's a couple drawbacks to that, and there's a reason that we don't do it at H&R Block. The drawback to doing a destroy run is that it still maintains TFC still has the last configuration that was pushed to it in the workspace. So if someone just hits run in the UI, that old configuration will get deployed again. And we don't want that. We want it to be clean and we're ready for someone to use. And if there is any mistakes, that nothing gets deployed that wasn't supposed to get deployed. So what we do instead is that we push a blank configuration and then we trigger a run using that blank configuration. And we do all of that with the API. There's some other advantages to that. Other things that we currently don't do, but other like kind of advantages to that method is that if you, in the process of checking out the workspace, providing a workspace to a developer, you wanted to provide a base level configuration, or you just wanted to deploy, the actual infrastructure for them to run their application, and then they can just deploy their application to that infrastructure. You can have that base level configuration deployed on check-in or on checkout, so that as soon as they have the workspace available to them, that infrastructure is also deployed and ready to use. We don't do that at Block. We allow our teams to self-service their infrastructure. So we give them an empty workspace that they can deploy the specific infrastructure that they need. And this example is going to show how we're doing a blank configuration in order to do a destroy, in order to clean up that infrastructure. So there's a few steps to deploying a empty configuration, or deploying an infrastructure, a configuration, and then running it with the API. The first thing that we're going to do is I'm going to add myself back into that workspace so that you can see the run when we trigger it. And then we are going to look at the workspace destroy. We're going to look at the workspace destroy script here now. So there's a few different pieces to this, like I said. First off, you need the workspace ID. So we're going to do a similar to how we got the user ID and the team's ID and the team ID. We query the list of workspaces and we search for the workspace name. And because we are searching for the name of the workspace explicitly, we only get the one result and we return that. Using the workspace ID, we can create a configuration that is associated with that workspace. In this case, we also need to provide, we also need to provide some additional configuration options. In this case, we don't want a run to start automatically when this configuration is pushed. The default is that when you upload a configuration, a run will start automatically, but that is not the behavior that we want today. So we set auto queue runs to false. There are other options. If we look at the documentation for that endpoint, there are some other options. We want to create a configuration. There are some other options. Here, you do auto queue runs, do a speculative plan, or provisional configuration. But the only one that we care about for this example is auto queue. We don't want it to run automatically when the configuration is uploaded. If we go back to our example, we will see that we generate this body payload, and then we call the workspaces configuration versions endpoint with the team API, with the team organization token, or the team token instead of the organization token. This is because the team that we're using has access to this workspace in order to create runs. The organization token is not able to create runs. One of the results in this, one of the values in the results for this request is an upload URL. And this gives you a URL that you could upload the configuration to. And then also gives you an ID of the configuration version that was just created. With that information, you can upload a configuration. In this case, it has to be it can be multiple files, but it has to be, or a single file, but it has to be in tar.gz. In this case, you can see that the configuration that I'm uploading is just a almost empty main.tf, a single Terraform block, and that's it, nothing else. So with this empty configuration being uploaded, any resources that were deployed from a previous configuration will get destroyed, and the cached configuration in that workspace will be an empty configuration. And I have made the tar.gz file ahead of time for us to use here. So with that blank configuration, we upload that file. Upload that file, and this is the only exception to what I said previously, where the headers will always be the specific content type and the specific authorization. The authorization is built into the URL that is provided as part of the upload URL, and then so the only header that you need to specify is that it's a content type application octet stream, because it is a zipped binary that we are sending up and not a JSON payload or anything else. Then we do a put request to the upload URL with the upload headers, and the data is the configuration file that we loaded into a variable using the open function in Python. When we get those results, we just get a pass or fail if it's successfully uploaded, or we get an error message. Once we have uploaded that configuration, then we need to create a run. That is why we need the configuration ID. A run is going to actually start the plan and apply for that configuration. And in this case, we need to have the workspace ID that we're starting the run in, and the configuration ID for the configuration that we are starting. And we build this payload here. We have the type of runs, and we have these attributes. We are setting is destroy to false, because this is not a destroy run. If it was a destroy run, we wouldn't need to provide a configuration. We could just start a run, as a destroy run, and it will just destroy the resources that are deployed. We can set a custom message, and we can set whether or not it's auto apply. If it auto apply, the default is false. If it's not set, if it is false, it will go through a plan and it will sit until it is approved in the UI. In this case, though, we want to automatically destroy anything when the workspace was deployed, so we don't need to actually check for the apply or check the plan. We want everything destroyed, so we're going to apply automatically. We set the workspace ID, and we set the configuration ID, and then we do a post request to the runs endpoint using this body, and again, using the team token and not the org token. And if it is successful, we will get a success code back. So if we run that, to destroy any infrastructure that was deployed, we get our workspace ID, and we upload our configuration, and our run is created. If we go to TFE to check on the status of that workspace, we will see, because it's an empty workspace, it was already an empty workspace, it is a very quick plan and apply because no changes were necessary. But you can see that API integration has triggered to run a few seconds ago, and we can look at the details of this run. HashiCorp demo, this demo API run is our custom message. And there was nothing in that workspace already, so the destroy run didn't have any changes to make. But if there were changes to be destroyed, it would automatically start the apply. And those are the main kind of endpoints, kind of like the main processes to managing an ephemeral workspace. You need to control access to the workspace, who can use it at any given time. And you need to be able to automatically destroy any resources when that workspace is no longer in use. We have used these endpoints specifically in order to create a workspace library application for our developers, for our application teams. That workspace library is a fairly simple application. There's a handful of workspaces that were pre-deployed, and when someone logs into that application, they can see a list of those workspaces. They can see a list of those workspaces, and they can pick which one they want to deploy and which one they can check out and deploy what they need to. And then when they check it back in, it will automatically get destroyed. You don't have to do it like we did. You don't have to build the whole rest of the owl. You can deploy, you can just put these in a pipeline. You can do whatever automation you like, or you can do it completely differently. But those are some examples of how we've used the Terraform API, Terraform Cloud API, in order to provide these services to our app teams. That is all I had today. Thank you for listening. Thank you for watching, and I hope we all learned something. Thank you.